Okay. All right. So today we're going to talk about areas of sectors and sine and cosine. So y'all have done sine and cosine before. You've actually done area of a sector and arc length before as well. So you do all of this in Math 3. So it's just kind of a review. Yes, I know that doesn't mean it's a review. Some of y'all are going to be like, I've never seen this before. Okay, it's okay. All right. So, all right. Basically what we got is in this circle, S is a fraction of the circumference of the circle. And the shaded region is a fraction of the area of the circle. Okay, we don't have a shaded region yet. Okay, but basically what you've got over here is this A right here is the area, correct? So that's just part of the circle. All right, and S is your arc length. Now remember we talked the other day about how R and R, right? So S and R here would be the same. If these two are R, then we would have the S here, depending if it is a radian. If it's not a radian, that doesn't apply. Okay. All right, so the fraction referred to above is the same as the ratio of theta over 360. And that's just kind of common sense. Okay, so let's just say, we're going to do a couple of examples here. Let's just say if theta equals 45 degrees. Okay, so we're just going to say that theta would be in here. Okay, it's that angle at the center. So if theta equals 45 degrees, then this would equal, using this conversion right here, it would equal 45 over 360. And again, that's just kind of common sense. What part of the circle is 45 degrees? Well, if it's out of 360 degrees, what does 45 out of 360 reduce down to? 1/8. Okay, so it is 1/8. So 45 degrees is 1/8 of the whole circle. It's the fraction of the circle. Is everybody with me? Okay. So to find our arc length over here, okay, so our arc length over here is going to be the letter S. We're going to take the fraction of the circle, which is theta over 360, times 2 pi r. What is 2 pi r? What formula is 2 pi r? Anybody remember? Circumference of the circle, right? But remember, we only want the part of the, we only want, like in this situation, we only want 1/8 of the circumference. Does that make sense? Okay, so you're doing the fraction now. Let's talk about some logistics here, because we can simplify this out to make a really easy formula. Super easy. 360 degrees and 2 pi. Are they equivalent? 360 degrees and 2 pi. Are they equivalent? Like when we did our unit circle, right? We got 360 degrees. If we go back around, is that the same as 2 pi in radians? Yes. Okay, so I know they're in different modes right now. One's in degrees and one's in radians, but they're ultimately equivalent. Okay, so technically we can cancel those out. So then what are we left with here? Theta and radius. So your formula for arc length is S equals R theta. Okay, that is going to be our formula that we use to find arc length. R being the radius and theta being our degree. Now that degree is going to be in radians. Okay, we will always use radians for this. All right, and then the other thing we want to talk about is the area. Okay, so same thing for the area of this part, just this part, we're going to take the fraction. So that's going to be theta over 360. And what's the formula for the area of a circle? Pi r squared. Okay, so 2 pi and 360 were equivalent. So what about pi and 360? What are they? 2 pi and 360 were equivalent, right? So where is pi in terms of 360? Half, right? So technically speaking, these two right here can turn into a 2 down here. Is everybody with me? Okay, so then in order to do that, to write our equation out for this, it's going to be A equals 1/2. So there's the 1/2 r squared theta. So r squared and theta. And that's your formula for the area of that part of the circle, area of sector. Okay? Now, make a little note somewhere over here that your theta must be in radians. It has to be in radians. So if it's given to you in degrees, you do have to convert. All right, so each one of these, we're going to find the area of the sector and the arc length. Okay, arc length, again, y'all, arc length, the super simple one is straightforward. The hardest example of today is going to be example number 2. It's the hardest example of today. Of the whole entire notes, the hardest example is example number 2. All right, easy example is example number 1. So here we go. Let's find the arc length first. So remember, arc is S equals R theta. Do we have our radius in example number 1A? Yes, we do. What is it? The radius is 11, right? What is our theta? 3 pi on 7. So all we're going to do is multiply those together. So 3 times 11 is 33 pi on 7 is your answer. So that is your answer for arc length. Okay, now we're going to do the area. So the area equals 1/2 r squared. So r again is 11, and theta is 3 pi on 7. Okay, so you can do this. Y'all can do it in your head if you want to. What's 11 squared? 121. Right? And 121 times 3. So I'm doing 11 squared is 121. 121 times 3. What's that give me? 363 pi on top, and 2 times 7? 14 on bottom. Now, if that reduced, you could reduce it, but it does not reduce, so we're not going to reduce it. All right, letter B. What's the first thing you notice, though, that's wrong with letter B? It's in degrees. It needs to be in radians. Okay, so we're going to do our conversions from yesterday. So if I want to convert 45 degrees to radians, I'm going to multiply by what? Pi on 180. Okay, so 45 over 180 is going to reduce down to pi on 4. So now we have our angle in radians. And now you go back and do the same thing we did over here. So S equals r theta, and our r would be 4, and our theta would be pi on 4. What happens to the 4's in that problem? They cancel, so our answer is just pi. All right, then same thing for area. Area equals 1/2 r squared theta. Okay, now I'll work this out. Remember, y'all can do this in the calculator. If you do it in the calculator, though, you need to leave what out? Leave the pi out until the end. Like, don't put the pi in the calculator at all. You'll just add it on at the end. But I'm going to work it out by hand. So what's 4 squared? 16. So if I keep going here, I would have 16 on top. So that's 16 pi. And then 2 times 4? 8. And what's 16 divided by 8? So the answer here would be 2 pi. Good so far. All right, so again, example number 2 is going to be the most confusing example of the day, okay, because it takes a lot of, like, you're going to get to one point and be stuck, and then get to another point and be stuck, and we got to figure out how to work them together, okay? So just hold on, buckle up, hold on. Here we go. All right, like this. All right, a sector has a perimeter. Okay, well, we haven't done perimeter yet, right? We haven't talked about perimeter, okay? But a perimeter of 16 centimeters and an area of 15 centimeters squared. Find its radius r and its arc length s. Okay, so let's go ahead and draw it out and see what we're dealing with. We've got a sector, right? So that's a circle. Okay, and we've got part of it. Okay, we know the radius is r. And if we're talking about part of it, our arc length over here is going to be s. Okay, so that's just what we had all the way up above. Just putting it back down here with this, okay? So the perimeter is 16. All right, that's the perimeter of the sector. So the perimeter of the shaded, this little part right here. Okay, well, what is perimeter? Well, how do you get perimeter of anything? Add all the sides, right? Okay, so what are our sides here? R, and S. So we can say that perimeter here equals 2R plus S. Everybody with me so far? Okay. Well, what is S the same as? Using our formulas, what's S the same as? R theta, right? Okay, so I can go ahead and say, all right, so P equals 2R plus R theta. Because I don't have an S, but I have an R theta. Okay, all right, so let's see. We know that the perimeter equals 16. So I can put a 16 right here. 2R plus R theta. All right, well, here's my first standstill. Because I don't know what R is, and I also don't know what theta is. So I still have two unknowns in this problem, correct? All right, well, that doesn't do me much good. Okay, so let's go and try another formula. So we've got perimeter, we've used that. They gave me also a number for area. So let's try to use our area formula. So remember, our area formula is 1/2 R squared theta. Well, here's why I like this already. Because I got an R theta here, and I can get an R theta here. So somewhere these two can relate. Okay, so I know that the perimeter equals 15. The area equals 15. So 15 equals 1/2. Now, what is R squared? What do I mean by R squared? R times itself. R times R, right? So I could really write this out. R times theta, right? Everybody with me? And now I have an R theta, which I also have in my previous problem when I got to my standstills. Everybody understand? Follow me here? Okay, so what I'm going to do is I'm going to go back over here, and I'm going to solve this equation for R theta. So in order to do that, what do I need to move? I need to move this 2R, right? So 16 minus 2R equals R theta. Now, I can take the 16 minus 2R and plug it in all the way over here for R theta. Now, how many unknowns do I have in that problem? 1, R. So let's work it out and see what we get. There's still a little bit of work to do, but we're getting there. I told you this must be the most difficult one. All right, what is half of 16? 8, so this is going to be 15 equals 8R, because the R is still there. And then half of 2? So minus R squared. Anytime we have a square or quadratic, we want that equal to, what do we want quadratics equal to? 0. So I'm just going to move everything over to the left. So that's going to be R squared minus 8R plus 15 equals 0. What am I going to do from here? Factor. If you need to draw it out, draw it out. That's going to be a 15 and a negative 8. And my two sides would be negative 3 and negative 5. So then what are my two R values? All right, so 3 and 5 are my R values. Okay, well, it said find the radius. Well, I've got 2. So if I have 2 radii, okay, then I also am going to end up with 2 arc lengths. Okay, because arc length is going to be different per radius. Okay, so we're going to have to plug them both in. So I'm going to go back over here. All right, and we know that R theta is the same thing as S, correct? So 16 minus 2R equals S, and I'm going to put in 3 for my first R. So 16 minus 2 times 3. You can't see it. Oh, it's on the wrong side. My bad. Thank you. All right, so S is the same thing, right? So I just went back and put S back in where R theta was. And then my first R is 3. So 2 times 3 is 6. What's 16 minus 6? 10. So when R equaled 3, S equaled 10. Is everybody with me? And then we're going to do the same thing for 5. So 16 minus 2 times 5. So 2 times 5 is 10. What's 16 minus 10? So when R equaled 5, S equaled 6. So there were 2 options there for your R and your S. And I'm not kidding, that's the hardest part of the day. That problem right there, hardest part of the day. All right, everything else, we're just applying this, and then on the third page, we're going to get to some stuff that you haven't done in a while, but you have done, obviously, before. All right, here we go. Next page. Make sure y'all can see it. Here we go. All right, apparent size. Apparent size is fun. All right. Apparent size is the measurement of an angle subtended at one's eye by an object. This is what y'all used to all do this when you were little, okay? You might do it when you're older. I don't know, okay? We'll see. This is what apparent size means. I'll wait for all y'all to get that written down, and then I'll show you, because it's really simple. Really quick. All right. So, if I am looking across my room, right, and I'm looking at the size of my board, okay, and I hold my fingers up in front of my face, and I make the size of my board, all right? So right now, I could squish the board between my fingers right now. Does everybody understand that? Is this the real size of that board? No. This is the apparent size of that board. Right here, that board looks that big, okay? If I take 5 steps closer, is that board still that big? No, now it's gotten even bigger. The closer I get to the object, the bigger its apparent size is going to be. Does that make sense? Okay? So like when you are looking up in the sky at a plane, right? That plane looks super duper small. When that plane is right in front of your face or you're walking on it, that plane looks ginormous. Okay? That's what apparent size is. All right? So basically, okay, don't judge my art ability or lack thereof. Lack thereof. Okay, this is an eye. These are my little eyelashes. Okay, so you're looking out at an object. Okay, let's say it's a person. Boom. Okay, I'm gonna squish your head. You know, like. Okay, but the closer I get to you, I can't do that, right? I'm gonna squish. But then when I get here, I'm nowhere near, right? Nowhere near. Okay. So that's what apparent size is. So basically how we relate this to what we're doing is when you look out, this little part right here is your diameter, which is also our arc length. And the apparent size is this little angle right here. Not too bad of a drawing. My eye is extremely larger than my person. But, you know, that's what apparent size is. All right, so example number 3, the apparent size of a tall building 2 kilometers away is 0.05 radians. All right, so again, not art class, so don't judge me. Just draw my little building. Okay, my building's going to have 2 windows and a door. If you're on the first floor, you can't see out, sorry. Okay? All right, so here's what they're saying for apparent size. All right, the apparent size of a tall building 2 kilometers away. So does the 2 go up the side of the building or does it go on the ground? 2 kilometers away. It goes on the ground, right? So the 2 kilometers is here. And it says that the angle itself, the apparent size, is 0.05 radians. So that's going to be my angle. What is the building's approximate height? Well, we're looking for the diameter, right, which is like our arc length here. Everybody got me? So it's just S equals R theta. What's our R? 2. What's our theta? 0.05. Multiply those together, what do we get? .1 kilometers. And so like today, earlier, they were like, that's really, really small. But 0.1 kilometers, I mean, kilometers is a large measurement. Okay? So, I mean, it's relative. That building's going to look very small from 2 kilometers away. Very small. All right. Example number 4, planet Mathematica. Has an apparent size of 0.01 degrees. Okay, so again, we're going to draw that out. So 0.1. Oh, no. What's wrong? What's wrong with it? It's in what? Degrees. Warning. We've got to convert. Okay, now, when we convert, y'all, we're going to leave that number on our calculator screen. I'm going to show you what happens if you don't, but we're going to leave that number on our calculator screen. So we need to convert 0.01 to radians. So that's going to be pi divided by 180, right? All right, so 0.01 times pi divided by 180. Okay. This is what you should get. What does e to the negative fourth mean? Anybody know? All right, that's like scientific notation, times 10 to the negative fourth. So ultimately what that means is there are 4 decimal places in front. So you would move this 4 places, 1 and then 3 more zeros. Everybody with me? Okay. But like I said, leave that on your screen. I'm going to write it out. I'm not going to write all these numbers down. I'm going to write it out. I'm going to cut it off and make it short on my paper. But for my calculation, I'm going to leave it on my screen. Okay? So on my paper, I'm going to write, that's the same thing as 0.123, let's say 17, we'll say 1745. Okay? Now, understand, there's a whole bunch of numbers after 45 that I left off. Is everybody with me? So leave this on your screen for now. All right, so now let's see what we got. They said that it was 8 times 10 to the 8th kilometers away. So that means this side right here is 8 times 10 to the 8th kilometers. All right, so S equals 8 times 10 to the 8th times this number. Now, the reason I'm just putting that there is because I'm going to leave that number there. Okay, so I'm going to do 8. Let me see if I can do it this way. 8 times 10 to the 8th times that number. Yay. Oh, calculator down. All right, so I just went up. Now, you could do it this way, too. You could just, if it's already on your screen, you can just hit the times, and it's going to take that answer and multiply it times 8 times 10 to the 8th. Do make sure the 8 times 10 to the 8th goes in parentheses. That's not a 10. And what do we get? 139626. 0.3402. Okay, so that's going to be in how far away? Kilometers. Okay, watch what happens, y'all. Let's say let's just say I used my rounded value. Watch the difference here. I'm going to do just 0.17 first. So 0.00017 times 8 times 10 to the 8th. Look at that value. Look how much different. That's almost 4,000 different. Okay, if I did the 0.0001745 times 8 times 10 to the 8th. That's closer, at least. We're only 26 off there. But do you see how I could, if I did 0.000174 times 8 times 10 to the 8th, the more decimal, you see how the more decimal places you add, the closer you are to the actual answer? Is everybody with me? Okay, but if at all possible, just leave it on your screen and use the whole value. All right, we good? All right, so yesterday we started talking about the unit circle. So remember, the unit circle is a circle with a radius of 1 and a center at the origin. So, looking on your regular, okay, if it's got a radius of 1, right? If it's a radius of 1, then what would this ordered pair right here be? So each one of these will be 1, right? Radius of 1, so what would that ordered pair be? 1, 0, right? What would be up here at the top? 0, 1. Over here would be negative 1, 0, and down here would be 0, negative 1. Is everybody with me? Radius of 1. Okay, and this will be our theta for whatever. Okay, and then basically this is just saying that for any angle theta, on the unit circle, there's exactly one corresponding x and one corresponding y. We good? All right, last page. All right, take us back to, like I said, something that you should remember, which are sine and cosine. All right, so the one that relates to x is actually your cosine, and the one that relates to y is your sine. Here's just how I remember this, y'all. I think about the alphabet. Which comes first in the alphabet, x or y? X. And C comes first in the alphabet. So X is your cosine, Y is your sine. I know a lot of times whenever you talk about sine, cosine, and tangent, you always say sine, cosine, and tangent because it just flows better than saying cosine, sine, and tangent. But cosine is your X and sine is your Y. All right, so let's make us a little triangle here. All right, so here's my initial radius. All right, so basically what we're going to do is we're going to drop a perpendicular straight down. So remember, a perpendicular line makes a 90-degree angle. So this would be my X and this would be my Y. X being my horizontal, Y being my vertical. Okay? All right, so if we're doing cosine, it's going to be X over R. Do y'all remember SOHCAHTOA? Y'all remember doing SOHCAHTOA? Okay, if this is your theta, right? And cosine is adjacent over hypotenuse, right? So adjacent here would be X over R is our hypotenuse technically, okay? And then sine would be Y over R. All right, last two examples. Well, technically three with an A and a B. All right, find the exact value of sine and cosine of an angle theta in standard position if point Q is on its terminal ray. Sketch the reference triangle. All right, so here we go. We got to draw this out. Where is the ordered pair 3, -4? What quadrant? 4, right? So we'd go over 3, right? And we'd go down 4, like so. Okay, so let's say there's an angle right there. 3, -4. So this is our angle. We would have started here, and we'd have gone all the way around. Okay, so I can make a triangle here with this side being 3, and this side over here would be -4. All right, now you may not remember your special right triangles. You may not have ever been taught your special right triangles. But you can find the missing side of a right triangle by doing what formula? What formula do you do the missing side of a right triangle? Pythagorean theorem, yes. Okay, so in other words, I'll work it out this time in case y'all don't remember, but 3, 4, 5 is a special right triangle. If you've got one side that's 3, one side that's 4, the hypotenuse is 5. It's one of your special right triangles, okay? But I will work it out using Pythagorean theorem. So if we're trying to find our hypotenuse, okay, that's going to be, in this situation, that's going to be r. It would be 3 squared plus negative 4 squared. All right, 3 squared is 9. Negative 4 squared is 16. Add those together, we get 25. And what's the square root of 25? Okay, your hypotenuse is 5. Will your hypotenuse ever be negative? No, because you're squaring a number and adding it. Does everybody follow? So that's not going to be negative. So our hypotenuse will be positive in all quadrants, okay? All right, so they wanted me to find the sine and the cosine, right? Let's find the cosine first because that's x. So what's my x value? 3. What's my r? 5. There's your answer. All right, sine. What's my y value? Negative 4. What's my r? There's your answer. We're going to change example number 6, by the way. You're going to use negative 12 over 13, not negative 3 over 5. All right, so let's go and move to the second one. Letter B. All right, so negative 3, negative 6, what quadrant are we in? Negative 3, negative 6. Quadrant 3, right? So if I drop my perpendicular, okay, we're at negative 3, negative 6. So now we need to find my missing side. I'll write it out again. Okay, so we're going to go r squared equals negative 3 squared plus negative 6 squared. All right, so that's 9 plus 36 is 45. And then we need to take the what? Okay, so you need to take the square root of 45. Don't tell me the answer is the square root of 45. Simplify down that. So square root of 45 is going to be 9 times 5, which is 3 square root of 5. Good job. Okay, so now our r is 3 square root of 5. All right, so now we can find our two values. All right, so cosine first. So cosine of theta is, what's our x? Negative 3 over 3 square root of 5. Can I leave it like this? No, I cannot. Okay, so I have to get rid of that radical. Well, first of all, what happens to the 3's? They can cancel, okay? So I technically just have a 1 on top now. But I'm going to multiply by the square root of 5 over the square root of 5 to get rid of that radical. So remember, those canceled. So now I just have the negative square root of 5 over, and when you do the square root of 5 times the square root of 5, the radical goes away, and what am I left with? What's the square root of 25? 5. So there is your answer for the cosine. So now we're going to do the same thing for the sine. What's our y value here? Negative 6 over 3 square root of 5. And again, we're going to have to multiply by square root of 5. Okay, so what's 6 over 3? Negative 2 square root of 5 over 5. One more. All right, again, make a change on here. Change that 3 over 5. It's going to be negative 12 over 13. Because we've already done 3 over 5 in the previous problem, so we're not doing that again. All right. Angle theta is in standard position with its terminal side in the third quadrant. Okay, so when I draw this out, okay, I'm going to be down here in the third quadrant. So let's make my triangle, right? Okay, and it's negative 12 over 13. Now, how do I know whether the negative is the 12 or the 13? Because that's sine, right? Which one's r? If that's sine, the bottom one's r, so my r has to be 13, right? And then sine, is that your y or your x? Is sine y or x? Sine is y, so I'm going to put it on the side. Okay, now is my x going to be positive or negative here? X is also going to be negative because we're in quadrant 3. All right, so now we got to do Pythagorean theorem, but this time it's backwards. They gave you the hypotenuse. You've got to go back and solve for one of the legs. Again, this is one of your special triangles. If you knew your special triangles, you wouldn't have to do the Pythagorean theorem. Just saying. Okay, but if I don't, I'm going to do, so 13 squared equals negative 12 squared plus, this will be x, right? So 169, 144. So if I subtract, I get 25 equals x squared. So what does x equal? X is 5. So now you need to find cosine. So cosine, remember, is x over r. So what's that going to be? Five over what? 13. Oh, negative 5, sorry. Should be a negative 5. Even though it told me 5, how did I know it was negative? Because we're in quadrant 3. My bad. All right, are we good? Oh, it's right here. No, it stays close to me. Thank you. All right, are we good? Everybody good?